In the name of God, hi, my name is Mohammad Mohsen. And this project I simulated and implemented a three-phase inverter because I want to be acquainted with basic inverters, and after that in the future I'm going to work on MMC modular multi-level converters. So I need to be acquainted with these basic inverters, so I decided to implement and simulated this very simple inverter. First of all, I'm going to work on its simulation. This project, I used a Plex software to simulate this inverter. As you can see, we have Series 6 MOSFETs here, and this is the DC link of this inverter. I used this PWM unit, which I designed it by myself, to create 6 signals with dead time. If I want to go through this unit, you can see that I have a constant here, which is going to be compared with 3 triangular waveforms, and each waveform has a 120 degree phase shift. So I used this circuit. It's not a circuit. I used these components here in this software to create dead time between 2 complementary signals. If I want to show that, as you can see, 2 signals, and if I zoom a lot, you can see they have dead time. Now I'm going to start the simulation. Again, phase of this inverter, as you can see, it's very clear. But I know that if you want to connect this inverter to electric machine, we need to use PWM, which I simulated here again. As you can see, 3 sine wave waveforms are comparing with this triangle wave. Now, if I want to show that, as you can see, it's very clear. PWM for 3-phase inverter, and the output of the output of this simulation is this. They have 120 degree phase shift. Now I'm going to show the setup that I implemented, and I'm talking about that. Now here we have the experimental setup. This is a 3-phase inverter and the gate driver circuit that I didn't design this and implemented this. I'm using this circuit, but this part I designed it, and I programmed this blue pill STM32F1, and this board on this breadboard, as you can see, is my dead time generator. My lamps, they are connected in delta connection. Oscilloscope, this power supply with 2 channels is my DC link, and this flyback, it's a flyback converter that I didn't design it. I'm using it right now. This flyback converter provides 6 isolated power supply for these gate driver circuits. Before starting to work on this 3-phase inverter, I'm going to talk about this setup. As you can see, I'm using STM32F1. This microcontroller creates 3 signals with 120 degree phase shift with each signals, and I'm using this circuit to change the frequency, and by changing this frequency, that phase shift should be maintained. So I wrote a program for this microcontroller to create 3 signals, and if the frequency changed, that microcontroller should be able to keep that 120 degree phase shift between each signals. These 3 signals come to this dead time generator that I designed it and implemented. Here you can see, and I have 6 signals out of this circuit with dead time. Before designing this circuit, I decided to use LM5106. It is it's very small IC, as you can see now. It's a half-bridge gate driver, but when I used this and I implemented, I realized that this circuit I cannot use it for low frequencies such as 2 Hz, 4 Hz, 6 Hz, 8 Hz, and 10 Hz, because I want to see these lamps blinking. Because of that, I decided to use these frequencies such as 2, 4, 6, 8, and 10. Now, I'm going to show that this circuit creates dead time between 2 complementary signals. I have to turn this power supply on. Okay, we have to wait for that. As you can see, these voltage probe are connecting to gate source of these MOSFETs, and now it is clear that circuit can create this dead time properly, and it's at 2 Hz. I can change it to 4 Hz. Okay, I'm using this circuit and changing. Okay, now it's 4 Hz. As you can see, these complementary signals. Again, I'm going to change it for 6 Hz. Hertz. Again, the gate source of 2 switches in one leg, they have dead time, and 6 Hertz. 8 Hertz, dead time. 10 Hertz, dead time. I can go back to 8 Hertz. Again, we have that dead time. 6 Hertz, that dead time. And 4 Hertz. Again, we have that dead time between these complementary signals. Okay, for the final stage, I connected the DC link to the inverter, and I'm going to turn this on. You have to wait for that. This is a link I'm using. I'm using these 2 channels in series, and this is our lamp, and now we can see that by changing the time division. Okay, 2 Hertz, and this is the result of simulation phase to phase, which is clear. And I'm going to change the frequency from 2 Hertz to 4 Hertz. Now start blinking, and now we have 4 Hertz, and that 120 phase shift between these waveforms, you can see it's remained. And now I'm going to change it from 4 to 6. Okay, wait a minute. Okay, 6 Hertz again, 6 Hertz, as you can see here. And now lights are blinking. Okay, it's very clear. And 6 Hertz to 8 Hertz, 120 degree phase shift has remained here, and I'm going to change it 8 to 10 Hertz. Again, it's remained 10 Hertz. Now lights are blinking, and the AC link, you can see 3-phase inverter. Okay, let me decrease the frequency. 8 Hertz again remained. The phase shift degree between these signals are remained. Now changing from 6 Hertz, as you can see, 6 Hertz. Okay, blinking, and 6 Hertz to 4 Hertz. Okay, 4 Hertz and 120 degree remained. And look at this. These lamps are blinking. So, in this project, I acquainted with this 3-phase inverter, and especially how to program a microcontroller to create 3-phase signals, and designing a dead time generator. And this circuit, you can see here, this circuit can create 6 signals with dead time, 2 signals for each leg with dead time, and that's it. I hope you enjoy it. I also designed its PCB, as you can see here, the dead time generator and other components and other circuits here, and this part of circuit is going to be connected to the LCD, and this is the microcontroller slot, and that's it. I'm going to put microcontroller on this board, and after that I can connect and disconnect this microcontroller slot to this circuit easily, and that's it.